Hey, so we are multiplying polynomials again. Throw your name on here again. And it is currently still second hour. So we should now have a basis of understanding basically how to distribute, how to multiply those coefficients and add those exponents. What we are adding in now is we are multiplying a binomial by a polynomial. We are actually going to multiply binomials by binomials and binomials by trinomials. So first of all, how many terms are in a binomial? 2. What is 2 times 2? 4. So we are going to be multiplying 2 terms by 2 terms. We are going to end up with 4 total terms. Then we're going to multiply binomials by trinomials. A trinomial is 3 terms. So we're going to multiply 2 terms by 3 terms. We're going to end up with 6 total terms, because 2 times 3 is 6. Crazy. So we're still multiplying coefficients. We're still adding exponents. What's new is that we have to remember to multiply every term by every term, which is why we're going to use these boxes. And at the end, there might be some like terms that we need to combine for our final answer. So every term in the first binomial distributes to every term in the second bi or trinomial. So 2 by 2 or 2 by 3, every term has to get multiplied by every term. If we were to just do that by hand, we would have to remember to multiply this guy by this guy, this guy by this guy, this guy by this guy, and this guy by this guy, which we could probably handle. But when you get to more terms, you got to remember to multiply the 3x squared by the 5x squared, the 3x squared by the x, the 3x squared by the negative 4, then go multiply the negative 2 by the 5x squared, the negative 2 by the x, and the negative 2 by the negative 4. Having to do all of that and just trying to make sure that we don't lose where we are is a lot. So that's why we're using this box method instead. And I put your boxes on there for you, so use them. So what we're going to do is we're going to take the first binomial, that 2x minus 5. We're going to put it over here on the left side of the box. Put the 2x on the top row, put the minus 5 on the bottom row. Then across the top, we're going to put the x and the 3. This is going to allow us to multiply every term by every term and know that if we filled out every square in the box, we've got everything taken care of. Okay, just like we did on 5.3, we're going to add in our imaginary ones. So this is 2x to the first, and this is 1x to the first. And then to fill out our boxes, it's the exact same. Multiply your coefficients, add your exponents. So 2 times 1 is 2. Add my exponents. 1 plus 1 is 2. So I've got 2x squared in that top left box. You can fill out your boxes in whatever order. I always go across the top and then across the bottom, but do whatever. 2x to the first times 3. 2 times 3 is 6. And I've got my x to the first. Okay, negative 5 times 1x to the first is negative 5x to the first. And then negative 5 times 3 is negative 15. Okay, so to fill out my boxes, I always multiplied the coefficients and I added the exponents of everything that was on the same row and the same column. Any questions about filling out boxes? Okay, so the box is a tool. That is not currently our answer. That's just a bunch of random things in squares. We need to turn it into an answer in standard form. So to do that, we're going to put it from highest to lowest exponent. Because these two guys were in standard form, your highest exponent is always going to be in the top left corner. Your lowest is always going to be in the bottom right-hand corner. And then everything else is going to go somewhere in between. It will kind of depend on what your polynomials were. So we'll start with 2x squared. So that's my highest exponent. Then I'm going to do my x to the first, but I can combine them. So this negative 5x to the first and this 6x to the first, those can combine together. So we're adding them. When we combine like terms, we add the coefficients. So negative 5 plus 6 is positive 1, x to the first. And I've still got my minus 15. Wait, any questions on that guy? Okay, so that's a 2 by 2. You end up with 4 terms total. Sometimes there's things that can combine. A lot of times there's things that combine. Sometimes nothing combines. So if there are no like terms, do not combine together things that are not like terms. Okay, next one we've got on here. We've got 3x squared minus 2 times 5x squared plus x minus 4. We are going to put the binomial on the side, because that's what I have it set up for. So this 3x squared and this minus 2 can go on the side. And then across the top, we've got our 5x squared, our x, and our negative 4. The only imaginary exponents we need to add in here is this x to the first power. You can add the 1 as the coefficient if you want as well. And then we can start filling it out from there. I like to do my top row first. So 3 times 5 is 15. Add my exponents. 2 plus 2 is 4. Three times 1 is 3. 2 plus 1 is also 3. So this is 3x to the third. Three times negative 4 is negative 12. And then this is x squared. That just distributes on over. So if you think about it, that row that we just did is like one of the problems we did in 5.3. Like honestly, that's me just distributing to each of these, okay? Then the bottom row would be like another row of 5.3. I'm just distributing the negative 2 to all of those. So, negative 2 to 5x squared is negative 10x squared. Negative 2 to 1x to the first is negative 2x to the first. I'm just multiplying everything by negative 2 at this point. Negative 2 times negative 4 is positive 8. Hey, questions right now before we combine like terms? Any questions about filling out our boxes? Okay. You're always going to start in the upper left-hand corner. You're always going to end in the bottom right-hand corner. Maybe some stuff along the way will combine. Maybe it won't. It kind of just depends. So 15x to the fourth, nothing to combine that with. 3x to the third, nothing to combine that with. If it's positive, put a plus. If it's negative, it's minus. Then this negative 10x squared and this negative 12x squared can combine together. So negative 10 and negative 12 make negative 22 x squared. And I've got minus 2x to the first plus 8. Alright. We've got one more example, and the reason why I added this one more example, because there used to not be one more example. I added this one more example because I wanted you to see more than one set of things combining. So, let's get the last one set up together, and I want you guys to test yourself filling out the boxes. So let's flip this over. I still see a couple people writing. I can't tell if they're writing on this side or the back. Alright, so on the back, let's put x plus 1 on the side. Oh, my pin bled through really bad. X plus 1. That can be 1x to the first there. And then 3x squared, negative 2x, and 5. And I can put my imaginary 1 there. Alright, go ahead and go fill out all your boxes. And then we're going to check them together. Use this as a test for yourself to fill out your boxes. Freezing my screen. I'm going to fill out my boxes. We'll meet back here in a second. Okay, once you get your boxes filled out, set your pencil down so I know that you're ready to move on. So I see like 4 people writing. Let's see if you agree with me. So on the top row, I got 3x to the third, negative 2x squared, and 5x to the first. On the bottom row, I got 3x squared, negative 2x to the first, and 5. Everyone have those in their boxes. Okay, so this one, when we go to combine like terms, 3x to the third is going to stay by itself because there's no other x to the thirds. What can we combine together now? Anything? What can we combine together? Yeah. Okay, this 3x squared and this negative 2x squared. So 3 minus 2 is 1. So that can be plus 1x squared, or you can just put plus x squared if you wanted to. Okay, what else can we combine? So this negative 2x to the first can combine with Thanks, Phoebe. I appreciate it. Negative 2x to the first and that 5x to the first can combine to be positive 3x to the first. And I still have my plus 5. So this is something you're going to see a lot, actually, with your 2x3s. Where you can combine at that diagonal twice. So, sometimes you can combine. Sometimes you can combine one thing. Sometimes you can combine two things. Sometimes you can combine nothing. We have an example of everything except for combining nothing. There's one on your assignment where nothing combines. So remember that nothing combines. There's also one on your assignment where one of the things that combines cancels out. If it cancels out, it cancels out. It's gone. Okay? I'm going to go ahead and stop this recording and get it posted.